So what we're going to look at today is called the dot product. And the operations we've done with vectors so far is we've added a vector to a vector. And when you do that, what kind of answer do you get?
It's a new vector.
A new vector. When you subtract vectors, you get
New vector.
a new vector. When you take and you scale a vector, you get,
Scalar.
well, when you do a scalar times a vector, what do you get?
Vector.
You get a new vector. It could be longer, shorter, or it could flip direction. What we're going to look at today is what happens when you do a vector
Scalar.
times a vector. What are we going to get? And that's what I'm going to show you. Well, first of all, when you talk about multiplying with vectors, you have to be more specific. You can't say multiply this vector times this vector. It's too big. When you do multiplication with vectors, there are two multiplication operations. One type of multiplication is called a dot product. The other kind of multiplication is called a cross product. And the way you know the difference between the symbols is if you see this, that means dot product. If you see this, that means cross product. We're not looking at cross products today. You also can't do a cross product in 2D. It doesn't exist. Cross product is strictly a thing that is a three-dimensional concept, not 2D. So that's one thing you have to clarify. We don't use the word multiply when we say a vector times a vector. You don't say times. You would say v dot w. So that way the person knows, okay, they're multiplying with a dot product. Or you would say v cross w. And because we're doing multiplication, we got to look at all the properties that we already know and see, do they still work? Could you switch the order and still get the same answer? Maybe, maybe not. We'll see. One of them you can, one of them you can't. We'll see which one the dot product is in a minute. So suppose you had these two vectors, v and w. v and w each have horizontal and vertical components. A1 and A2 are the horizontals for v and w. B1 and B2 are the verticals. And remember, those would all be numbers. Those would all be numbers. 2i plus 3j, 6i minus 7j. Something like that. Yes?
Kind of a weird question, but could those numbers technically be fractions or have decimals, or do they have to be whole numbers, like just 1, 3, 1, 2, 3, 4, 5?
There you go.
So like not pi, not the I, not the square root of -1 stuff. So just
Real numbers.
okay, yeah.
They would all be real numbers. So the dot product, it's a very, very simple calculation. You take the two horizontal components, multiply them together. Take the two vertical components, multiply those together. And then you add the result. So based on the formula that I have there, what kind of answer do you think you get when you do a dot product? Yeah? It's what? Right, it is a number. What that number means, we'll talk about later. It's not a magnitude, but it is a number. 12, 37, 56, okay, whatever it comes out to. But the point here is when you take a vector, dot it with a vector, the answer is a number. And I'm going to show you what we do with that number in a little bit. Okay, so let's take these two vectors, 2i minus 3j, 5i plus 3j, and I want to find the dot product between them. Okay, what would be the first two things I would multiply together if I'm finding the dot product between V and W? Yep.
2i and 5i. 2 and 5.
2 and 5, right? It's just the things that are in front of the i's. So 2 and 5. Yep. Okay, so you start with that. And what would come next? 2 times 5, yeah?
Would it be negative 3 times 3?
And negative 3 times 3. Hey, what's that dot product going to come out to? Yeah.
10 plus negative 9. Oh, do we include the I and the j? Or...
Nope, just final answer.
Oh, you combine the sorry about that. Then that'd be 1.
1. Yeah. So the dot product in that case is 1. Okay, what I want to look at now is what if I do W dot V? So I'm basically checking the commutative property. Can I switch the order and get the same thing? If I do W dot V in that order, what would be the first two things I multiply? Yep. 5 times 2. Yep. And what would be the next two? Yep.
3 times negative 3.
3 times negative 3. So what does that come out to for a dot product?
It's still going to be 1.
It's still 1. So that means the dot product, it doesn't prove it. It shows it in this particular example. But in general, the dot product is commutative. If you change the order, you still will get the same answer. Okay. Any question on that one? Yes.
I know it says A1, A2, but like, why don't you include the I's and the J's in the answer?
It's just not, because the dot product doesn't have a vector. Dot product is a number.
Okay. Because I was going to say, if you multiply them together, you should end up with I squared and J squared.
Yeah, no, you don't use the I and the J, just the components of the vectors. Now when we get to 3D, instead of 2 components, there'll be 3. But we're going to do it pretty much the same way. All right. How about V dot V? I want to do V dot V. Okay, so what would I multiply together first if I'm going to do V dot V? Yeah? 2 times 2. Okay. What would I multiply second? Yep.
Negative 3 times negative 3.
Negative 3 times negative 3. Now, I'm not interested in the answer right now. I just want to think of this a different way. What's another way to say 2 times 2? Yep.
2 squared.
Right. 2 squared. And what about negative 3?
Negative 3 squared.
Negative 3 squared. So before we simplify it, what is this kind of like doing? We're taking this component squared, we're taking that component squared, we're adding them up, and then we're stopping. But it's very similar to something we did yesterday that had one more step. Yeah? Right, it's kind of like finding the magnitude. You square this, square that, add them up. What you're missing is taking the square root. Okay, we don't do that when you're doing a dot product. So in this case, you're going to get 13. Now, what would the magnitude of V be? Yeah? It would be the square root of 13. Okay? So dotting a vector with itself doesn't quite give you the magnitude. It gives you the magnitude squared, because you didn't take the square root. So dotting a vector with itself squares the horizontal, squares the vertical component, and it adds them up. It just doesn't take the square root. Any question on that idea? Dotting a vector with itself gives you the magnitude of the vector squared. All right, so let's try this one. Okay, evaluate 2, 6, 0, 0, and I'm finding the dot product. Okay, what's going to be the dot product between those two vectors? Yep.
It should just be 0.
0 as a number or 0 as a vector?
0 is a number.
Right. The answer here is a number. Not a bold 0, not a 0 with a line on top. It is the number 0. That's the answer. So it's 2 times 0 plus 6 times 0. That's 0 plus 0. Yes?
So obviously, like a quick question is probably gonna be like, do the dot of like these two specifically, but for when we're like solving something out, does it like matter if we use like an asterisk or the x or the dot if we're just doing like for the regular other stuff for vectors, like finding the magnitude and all that? Does it matter what symbol we use as long as
No, if you're doing arithmetic multiplication and you're used to using whatever symbol you use, that's fine. But when you are multiplying vectors, you need to use either this symbol or that symbol.
and they have different meanings?
They have a very different. Yep.
Thank you.
Yep. All right. So one thing that is also true about dot product is it is distributive. If you have two vectors being added or subtracted inside parentheses, and you have a dot product on the outside, you can do u dot v plus u dot w. Okay, so you can do the distributive property with dot. So what we really use the dot product for, one thing we use it for, is to figure out the angle between two vectors. Now, I'm going to show you a formula to do it, but we technically don't need the formula. Let's look at, let me pull up a grid and show you something. Let's do this. Maybe. All right, and let's say, make that grid a little bigger. Let me draw two vectors. I got a vector like that, and another vector like that. And I wanted you to figure out the angle right there. How could you figure out that angle?
By utilizing either law of sines or law of cosines, if we are given other information.
Which law would you have to use? It is one of those.
But what other information are you given?
That's it.
So you're told what the vectors are.
Mm-hmm.
Okay, so that would be side angle slides. That's going to be law of sines.
You don't know that angle. That's what you're trying to find. Yep.
No idea.
Law of cosine.
Right. You could use law of cosines. How come? Yep.
If we turn it into a triangle
Yep.
by connecting those 2 points, we have side, side, side.
Right.
We just need to figure out what that other one side is.
Yeah. You have all the sides there.
Because of the grid there, it's easy to find out.
Yep. You can do your Pythagorean theorem on all those vectors. Use the Pythagorean theorem 3 times. Find the length of each one of those sides. Then you would know side, side, side. and then you could use the law of cosines to get the angle between those two vectors. So the formula that I'm going to show you is based on the law of cosines. It has a cosine in it. But it takes all the work of using the Pythagorean theorem 3 times, then doing the law of cosines, and compresses that all into a much simpler formula. Okay, there is an easier way to do it. And that's what I'm going to show you. Okay. So to find the angle between two vectors, it's the dot product over the product of the magnitudes. And that comes directly from law of cosines. That's exactly where that formula is from. I've done the proof before. It's not that hard. It'll probably take about like 5-7 minutes to do it. But for the purpose of what we're going to do is, I'm more interested in getting to an application of this rather than proving the formula. Okay, I want to get into a word problem. Okay, thank you. Okay, and just in case you don't remember the bottom, those symbols mean magnitude. So the denominator is the length of u times the length of v. So in the end, we're going to be trying to get the cosine by itself. Or get the theta by itself by getting rid of cosine. How do you get rid of cosine and get theta by itself? Yeah?
Inverse cosine.
Yeah. So this is going to use the inverse cosine at the very end, just like we would do if we were doing law of cosines and we were solving for the angle. But this is a lot faster than using law of cosines. Okay, so here's your two angles. Here's your two vectors. I want to find the angle between them. Let's sketch them and see roughly what we think the angle is. Let's find it, and then see if it matches what we think. Okay, so let's take that. Make the grid a little bigger so it's easier to see. So we've got 4i minus 3j. So let's start here. 1, 2, 3, 4. 1, 2, 3. Okay, so there's vector v. Or I'm sorry, that one's u. Let's fix that. And w is 2i plus 5j. So let's go 2i, 1, 2, 5j. 1, 2, 3, 4, 5. Okay. What does it look like the angle is between those two vectors? Roughly, yeah?
Obtuse.
Can you throw a number on it for me?
100.
Yeah, maybe around 100, you know. It's more than 90, but it's not 180, so it could be around 100. Yeah. So now let's find it and see if it looks like we did it right. Okay. First thing I need is the dot product. Then I need the magnitude of u. Then I need the magnitude of v. And I plug them all in the formula.
And then we're going to need the magnitude of that third angle or side.
No, we're not going to need the third side because we just need the length of two sides in the formula. Just the u and the v. This formula shortens the amount of work from the law of cosines. Okay. So what is the dot product of u and v? Yeah.
4 times 2 plus negative 3 times 5.
So the dot product is going to be 8 minus 15, which gives me, yeah, negative 7. Okay, so there's our dot product. What's going to be the calculation for magnitude of u?
is going to be u squared. I mean, wait, magnitude u squared. You literally just had it up there. Cosine theta equals uv over the magnitude of u times the magnitude of v.
And what's the magnitude of u? That's what I need.
Five.
Okay, how'd you get that?
Because like the 4 squared plus 3 squared is Pythagorean theorem. Sorry, it took me a little bit to get there.
So 4 squared, yep, perfect. Plus 3 squared.
Squared.
And then you take the square root of that. So the magnitude of u is 5. And what's the magnitude of v going to come out to?
Square root of 29.
It's just going to be the square root of 29. Now, fill in the 3 things I have circled into cosine theta equals the dot product over the product of the magnitudes. Equals, I think the dot product is -7. Okay, and what do we do to get theta by itself?
Inverse cosine.
Okay, so the angle is the inverse cosine of -7 over 5 square roots of 29. And let's see if we get something that's around 100 degrees. So -7 divided by, if you want to type it all in at once, that's fine. But type it in exactly how I just did, with the parentheses. Yeah, it seems reasonable. We thought it was about 100 degrees, and it says it's 105.07. I would say 2 decimal places for this is pretty good. 105.07 degrees. Okay, so when we're finding the angle between 2 vectors, it's always the angle inside them. If you wanted the one outside, well, you could just subtract from 360 to get that. But we're focusing on the angle that's between them. So the angle that we're going to be calculating is always 180 or less. All right, any question on that? But that's not anything special, 105.07. There is an angle that if it comes up, this would be special. Can anyone think of an angle that 2 vectors might form, and we would consider that special? Yep. 0. Yep. 0 is a special angle. Yep.
360.
So that's the same as 0. Yep. How much? Yep. 0 and 180 are actually fall in the same situation, but they are special. And there's one other one. Yep. 90. Yep. So let's talk about 90 first. So 2 vectors are perpendicular. It means the angle between them is 90 degrees. The word they use to describe vectors being perpendicular is orthogonal. That's the word. Okay, orthogonal means 2 vectors that are perpendicular or meet at a 90-degree angle. So what I want to do is kind of work backwards, already knowing, let's say we already know the angle is going to be 90. What's going to happen in our formula? So let's think about the formula. What's in the top of our formula? Like in general, it's
The
yep.
dot of the vector.
It's a dot product, yeah. So we have a dot product in the top, and what do we have in the bottom in general?
Magnitude.
We have a magnitude. Anything else?
Magnitude.
Times the magnitude. So I want to work backwards and figure out what's going to happen over here that results in a 90-degree angle. Okay, so let's start with this. What is the cosine of 90 degrees?
0.
Think of 90 degrees on the unit circle and think of the x value. Yeah? It's 0. If you have an angle of 90 degrees, that means the left-hand side is 0. Well, the left-hand side is equal to the right-hand side. What would have to happen on the right-hand side to make that equal to 0? Yep,
Dot product has to be 0.
exactly. The dot product would have to be 0. So that's a quick shortcut that we can use to figure out if two vectors are orthogonal. If their dot product is 0, they are automatically orthogonal. You don't need to figure out anything else. Let's see. Yes,
What would the angle be if they were orthogonal?
90.
90.
Yeah. So if two vectors are orthogonal or perpendicular, then their dot product is 0. Okay. So what I want to do is see if these two vectors are orthogonal. I've got 2I plus j, and I have I plus 2j. All right, let's find the dot product. What's the dot product between V and W? Yep, it's 4. So that should answer the question. Are these vectors orthogonal? No, they're not orthogonal. So if you could change one thing, you can only change one thing, what could you change to make them orthogonal? Yeah? Yeah, you could just change the sign of one of the numbers. If you make any one of these a negative, the vectors will automatically meet at 90-degree angle. Yep. Okay, so that's orthogonal. The other case we said about 0-degree angle and 180-degree angle. What do you think? What do you think the vectors would be if they? Yeah. What do you think the vectors would be if they met at a 0-degree angle? Yeah? Parallel? How about 180? Yeah?
They'd be like the opposite value of each other. So if one of them was, like if it's parallel, like you can look at it as,
So I'm looking for a single word. You can only give me one word. If they meet at, what angle did you say 0 was what? Parallel. Okay, how about 180? Yeah?
Parallel.
Also parallel. Yeah. The difference is basically two vectors like this versus two vectors like that. Okay, when they're pointing in exactly the same direction, if you line them up on top of each other, the angle between them would essentially be 0. With 180, if you line them up like this, you can kind of see it a little better. The angle between them is 180, but that's really like what I just drew right here. Those are also considered parallel. Right? So both cases are parallel. So what I want to see now, is there a shortcut for that? Okay. Is there a shortcut if the angle comes out to 0 or 180 that we can quickly tell? Well, let's see. If the angle came out to 0, okay, you'd have the dot product over the product of the magnitudes. What is the cosine of 0? Think of the x value of the coordinate for 0 degrees. Yeah? 1. All right. How can a fraction come out to 1? What has to happen? Yeah?
divide by itself.
Yeah, so you have to have something divided by itself. So what does that mean you would need to know in this fraction to figure out if it's 1? Yeah?
One of the magnitudes or the dot.
Yeah, you need both. You can't figure out if the fraction comes out to 1 if you only know the top or you only know the bottom. You need both. So the answer here is no, there isn't as much of a shortcut. You have to find the top and the bottom. Now, let's look at what happens when it's 180. What's the cosine of 180? Yeah?
Isn't that -1?
That's -1.
So you can,
How can a fraction come out to -1?
the way you can do that is by having either the top or the bottom be a negative number. It can't be both of them, it needs to be only one of them. The other needs to be positive.
So like -5 over +10?
They need to be the same as well.
Oh, okay. So they have to be opposites. Yeah, so you have to have opposites. But to know if these numbers are opposites, you need both. You have to know the top and you have to know the bottom. So again, there really is no shortcut for parallel. Okay, you got to find everything. Yep.
I thought like if we're looking at the dot with magnitude times magnitude, like oh wait, when I thought it was like the same magnitude, so even if they were both -1, it would still come out positive. So but they're different magnitudes, so it can still come out negative.
Yeah, well, the bottom is always going to come out positive. There's no question about that because it's a magnitude times a magnitude. So the only way you can get a cosine, the only way you can get a negative number out of that fraction is if the top number is negative. The bottom number will never be.
Yes, isn't that the shortcut that you just need to look at the dot and then if it's a negative, you already have it?
No, because you got to know the bottom number too.
Oh, it's not just negative numbers, it's -1.
Yeah, it has to come out to -1, which means you need the top and the bottom number.
Sorry.
Yeah. All right, well, let's try this one. Okay, dot product. What's 4 times 20?
80.
80. What's -5 times -25?
125.
125. Okay. So the dot product is 205. I can't tell you if they're parallel, but I can definitely tell you if they're perpendicular. Are they perpendicular? No. It would have had to come out to 0 for a dot product. Okay, so I don't know if they're parallel. Magnitude of V. It's going to be the square root of
4 squared and 5 squared.
Square root of 41.
square root of 41. Yep. And magnitude of W is going to be 1025.
Yeah.
Right? Yeah. Yeah. Fill all that into the formula. Or, we don't even need to fill it into the formula. All we have to do is check, do these magnitudes multiplied together give us 205? If they do, then we would have the same number in the top and the bottom of the fraction, which would mean they're parallel. All right, let's see. Square root of 41 times square root of 1025. The product of these is 205. So what does that mean about V and W? Yeah.
So we can infer that it's 180 degrees.
Yeah, they're going to be parallel. But the angle is
that's their 0 degrees.
0 degree angle. Yeah. Yep. So these vectors are definitely parallel. Any question how we figured that out? Once you know the top and the bottom are the same, you can, I guess you can stop there. You don't have to do inverse cosine. It's a little bit of a shortcut, but not like perpendicular. Okay. Any question on that? All right. Last question. Okay, so we have an airplane. In this problem, it's important to understand the difference between two terms. There's going to be ground speed and there's going to be airspeed. Okay, the difference between the two can basically explain it with a car. So if there's no wind outside, no wind at all, and you're in a car going 40 miles an hour, and you put your hand out the window, how fast would the wind be hitting your hand?
40 miles per
40
hour.
miles an hour. And the speedometer would say 40 miles an hour. Okay. Now, let's say that there's a wind of 20 miles an hour, and you're driving into the wind. Your speedometer says 40. You put your hand out the window. How fast is the wind hitting your hand?
60 miles per hour.
60. Okay, the speedometer is not going to say 60. The speedometer is going to say 40 because you're going 40 miles an hour, but you're driving into a wind that's coming at you at 20. So it's like you're hitting, the wind's hitting you at 60. Okay, that's the difference between ground speed and airspeed. So ground speed for an airplane would be like if you had a radar gun and you could somehow track the plane moving, how fast is it moving across the sky? Airspeed is if somebody put their hand out the window, how fast is the wind hitting the plane? Right? That's the difference. And if there's no wind at all, then there is no difference. Ground speed matches the airspeed. Okay, so this plane is maintaining an airspeed of 500 miles per hour. And it's going south. It's going directly south. There's also a jet stream. Okay. Most of the time, I'm going to have the jet stream be one of 8 directions. Directly north, south, east, west. Or exactly between the two on like a 45-degree angle. I mean, technically, the jet stream could be any angle at all. But I'll have it be one of those 8 directions.
So it's either going to be one of the 90, 0, 180, or 270.
Yep. Or like a 45, 135, 225, or 315. And it's important to understand what angle northeast is. Because we need to convert, we can't really use northeast in an equation. You need to change northeast to a number.
It's going to be directly 45.
It would be 45 degrees, yep.
And then the airplane is heading at directly 270.
The airplane is heading in a direction of 270 degrees. According to how we label angles, that is not how a compass labels angles. Okay, I'm not worried about how compasses work, I'm more worried about how the numbers we use work. But south is 270 for us, because south is down. All right, so the question is, find the actual speed, basically find the ground speed, and the direction of the airplane, taking into account the jet stream. Okay, so what I would do first is I would try to visualize what's happening here. Okay, what is the direction of the airplane? Yep.
600 degrees.
Right, it's heading south at 500 miles per hour. In terms of the vector, that 500 is like my what?
Magnitude.
It's the magnitude. It's the length of the vector. So that the vector that represents the plane is going to be a lot longer than the vector that represents the jet stream. It's going to be 80 miles an hour versus 500. So let's draw the vector for the plane. So here, okay, let me draw that a little better. Okay, so we'll call that the vector for the plane. Okay, which way is the wind blowing? Yep.
45 degrees.
It's blowing at a 45-degree angle, and it says jet stream is blowing in a northeastern direction. Now, you have to pay attention to how they word the wind direction. This one is pretty clear. It says the wind is in a northeast direction. If it's, you could also word this problem by saying the wind is coming from the southwest. If wind is coming from the southwest, it means it's blowing to the northeast. Okay, so you have to be careful with the wording. Right? So like on the news, if they say the winds are coming from the west, the winds are coming out of the west, that means they're blowing east. That's the direction. Okay, but this one words it clearly. Jet stream is northeast. Let's draw that. Again, it's not to scale, but it is shorter than the vector for the plane. Okay, let's call that the vector for the wind. What I want to find is the actual direction and the actual speed of the plane, combining those two vectors together.
So I thought the plane was going south, which was 270. Wouldn't that be like?
Yep, south is the green arrow.
So it's going from like 0 degrees. The
0 is over here.
left. Okay.
Yep. Not on a compass, but
Yeah.
in math class it is. So that's 0. Okay, so how could I get the actual vector for the plane as a picture? Okay, we did this on Monday. What could I do with those two vectors to get the combined result? Yeah.
You'd use the terminal VW and the terminal VP and create a new line.
Yeah, we'd have to position this one. Just gonna make a copy of it
Yeah.
temporarily.
Yeah.
You'd have to line up the beginning of one with the end of the other, and then draw in a vector like that. So that arrow in black, that's the actual speed and direction of the plane. We'll call that V sub, vector sub actual. Is it going faster with the wind or slower?
Slower.
It's slowing it down. The plane's trying to go south, the wind is coming at it at an angle. The wind is trying to blow it northeast. So the wind is going to slow it down a little bit. And it's going to blow it off course a little bit. Unless they correct for that. Okay? But if they don't correct for it, the wind is going to take it off course a little bit. Okay, so let's figure this out. What do you think we need to do with these three vectors that we have as images? Yeah.
We need to like actually make it a triangle.
Uh,
Well, no, like
sure.
actually put the values in, like with magnitude.
Right, we need to convert V sub W and V sub P to velocity vectors. That way we can start working with them as numbers. Okay, so remember the formula for velocity vector. Magnitude times the cosine of your angle is the horizontal. Magnitude times the sine of the angle. That's the vertical. So let's start with the plane. What's the magnitude of the plane?
500.
500. What's the angle of the plane?
Oh, wow.
270.
270. Okay, so that's your horizontal component of the plane. Now think about it. The plane is going south. So what should the horizontal component be?
Oh, 0.
It should be 0. So that part shouldn't even matter. What's going to be the formula for my vertical component?
The wind speed.
The vertical component for the vector for the plane.
Oh, the plane. That would be 0. Wouldn't that just be 0 cosine? Like, wouldn't that just be 0? Oh, sorry. That would. I give up.
Yeah. 500 sine 270 J. And because it's going directly south, what kind of number should J be? it should be a negative. Okay, so let's do those out, but I think we already know what's going to happen. 500 cosine 270, there is no horizontal component to the vector for the plane. It's not going left or right. So that's 0i. And then 500 sine 270 is negative 500j. All the vector for the plane is going straight down. It's not on an angle down, it's straight down. So it's negative 500j. Okay, so there's the vector for the plane. What's the other vector that I can figure out? Yeah?
VW.
Right, the vector for the wind. I can only figure out the actual vector by combining v sub p and v sub w together. I don't know v sub a. I have an image of what it looks like, but I don't have any numbers for it. Okay, but VW we do. Okay. Vector for the wind. What's the magnitude of the wind?
80.
80. What's the angle of the wind?
45.
Yep. So we're going to write 80 cosine 45 plus 80 sine 45. Now, since it's blowing at a 45-degree angle, what do we know about the horizontal component of the wind and the vertical component of the wind? Yeah?
So for the unit circle, the 45 degrees is like the 2 over pi coordinate thing. Like it's the x and the y values are the exact same.
Right. The components for the horizontal and the vertical part of the wind are exactly the same. So once we figure out one of them, we automatically know the other one. So you don't need to type 80 sine 45. It's going to come out to 56.57. Same thing. So if you wanted to simulate an 80 mile per hour wind on a 45-degree angle, you could just have a 56 mile per hour wind blowing right, and then another 56 mile per hour wind blowing up, and you would get an 80 going up and to the right. Okay, so we have the vector for the wind. Now, I want to find the actual vector for the plane. How did we get v sub a in that picture? I'm looking for like a formula. How did we get v sub a? Yep.
Could you try the system of equations that we did? Like,
Well, I'm looking for the formula that we already used to draw it. Like, how did I draw that vector in black? That wasn't just a random guess that I did. It was based on what's up there. Yeah.
so like, what was it? VP minus VW?
It wasn't VP minus VW. Yes, it was the sum of the two. VP plus VW. That's what I want to figure out now numerically. Okay. Vector for the plane, negative 500j. Vector for the wind, 56.57i plus 56.57j. Okay. And then what could I do there? Yeah.
Combine terms.
Yeah, combine like terms. So we have negative 500, and we're going to add 56.57. So that gives me a new velocity vector of 56.57i. There's nothing to combine with the I, so that's going to stay the same. But for J, I get negative 443.43. So that represents the actual vector for the plane.
Wait, wouldn't it be J?
Yeah, J, thanks. Yeah, that's J. All right, now what I want to know is this. That's the ground speed of the plane. That's the actual speed the plane is like moving above your head. What would be my formula to find the actual speed of the plane? The ground speed. Yep.
Square root of 56.57 squared plus 443.43 squared. And the negative doesn't matter because it's going to cancel out to be positive.
Yep.
When you do that, it'll be the square root of 1. I have it still on the square root.
Oh, you have it without the square root. Yeah, you can do it without the square root if you want, or you can do it all in one step. That's the actual speed of the plane. So it's not going 500 miles an hour from your perspective on the ground. The wind is slowing it down. Even though the instruments in the plane may say it's going faster, not to you on the ground. The wind is blowing faster, but not the movement of the plane. Okay. So 447.02. And the opposite could happen if the wind was behind the plane, pushing it forward, right? That you could actually make the plane look like it's going faster than it says they're going, because the wind is helping. All right, so we got the actual ground speed of the plane. I think that's fine, because if you wanted the angle, well, we already talked about how to do that. You could find this angle right here if you wanted to, or I think maybe they wanted to know this angle. So let's say when you do the dot product over the product of the magnitudes, let's say that angle comes out to 10 degrees. I don't know what it is exactly. Let's say it came out to 10. Then you could say the plane is flying at a 280 degree direction. It's a little bit east of south. 10 degrees east of south. Or whatever it comes out to. It might not blow it off that much, but
What law thing would you, what property thing would you use? The sines or the cosines? Because I can never remember what.
to find this angle,
What side angle side, yeah, is.
you would use the formula that we had when we talked about the angle between two vectors. That formula right there.
Oh, goodness.
As long as you have two vectors, which we already do, we wrote them down, you could find the dot product and the product of the magnitudes between VP and VA. Just use these numbers right there and right there. That's VP and VA. So that finishes everything in 2D. Okay, we've talked about everything that we're going to be doing with 2D vectors. Tomorrow we'll look at 3D, and we basically do without applications. We do everything we did in 2D. Again, we look at all the formulas, but without the applications, it goes a lot faster. And then the final thing we look at in 3D is a cross product. Okay, we never looked at cross product in 2D because it doesn't exist. Can't do it. All right, so that's the homework for tonight. On 7 through 17, each question has 3 parts. I think the first part says, find the dot product. The second part says, find the angle. And the third part says, are they parallel, perpendicular, or median? So it's not like 3 different questions. They're all related to finding the angle. 25 is a word problem about an airplane with a lane. Oh, but the other ones have 3 parts?
Yeah.
Okay.